Hi, kids. Hey, we're going to talk about gravitational fields. Okay, the symbol for a gravitational field is just this lowercase g. Okay, we already know, or you already know, that near the surface of the Earth, the gravitational field strength is 9.8 meters per second squared, or if you want, 9.8 newtons per kilogram. But let's kind of draw it. So let's say if you're near the surface of the Earth looks flat. Okay? As long as you're near the surface of the Earth, it's. And if I was to say, well, if I had an object here, or an object there, an object there, an object there, if you were to say, well, draw what the gravitational field looks like, it's just a bunch of arrows pointing straight down. Why? Because that's which way that gravity's going to pull things. It pulls it straight down. But you'll notice, do you see how these arrows are, at least if I drew it correctly, they're all equally spaced. That means that g is constant near the surface of the Earth. Hence, all bodies fall with the same constant acceleration. Okay, if it's the Earth, g is 9.8 meters per second squared, or g is 9.8 newtons per kilogram. Remember, newton per kilogram, same thing as meter per second squared. Okay. Universally, though, so like if I'm not near the surface of the Earth, so like we're looking at the Earth looks like this. If I was to say, hey, draw the gravitational field, it would look something like this. And you'll notice, do you see how the field lines are getting further apart as you go away? Well, that's because as r goes up, g goes down. Okay, the gravitational field strength gets smaller. Okay, so then, well, how do we find the gravitational field strength? Well, this is where near the surface of the Earth, we use this equation, Fg equals mg. Universally, we used this equation, gmm over r squared. Well, if I set these two things equal to each other, because, I mean, this is true, it's just, I want to make sure you understand, this is true over here, it's just that g is not 9.8 over here, okay? But I can set these two things equal, and when I do that, I get mg equals gmm over r squared, and you'll notice, okay, this is why I like to make big M's and little m's. My little m cancels. Well, what is it that's canceling? Oh yeah, whatever it is that I'm putting in the gravitational field. You know, just like before where we said all objects fall with the same constant acceleration, because m cancels out, because you had, if the only force acting is gravity, m cancels out, a is 9.8 meters per second squared. Same thing, that, hey, my mass, whatever mass I'm putting in the field cancels out, so I end up with g equals gm over r squared. Now, some of you might be going, geez, I need to memorize that. Well, no, you don't need to memorize that, because you know this, you can easily solve for this. In fact, on your formula sheet, if you look, okay, let me zoom in so you can see. Okay, right here, there's your universal law of gravity. Hey, look, there's this equation. If I take this and I plug it into there for Fg, I end up with, let me zoom back out, I end up with this right here. Okay, so you get that. So the gravitational field strength is gm over r squared. So, you know, this is proportional to the mass of whatever it is you're around, and it's proportional to 1 over r squared. All right. Hope that helps. Bye, kids. Actually, you know what? Before we go, let's do one just quick practice problem, because it's always good to practice proportional reasoning. So let's say you are on planet X. Planet X. And let's say planet X has a mass that's 3 times the Earth. And planet X has a radius that is, what do you want to do? Like, we'll make it a really dense planet, so it's 1/2 of the Earth's radius. And so then the question is, what would the gravitational field strength on planet X be? Or if you were to travel to planet X, how many more, how much more or less would you weigh? Okay, so if we wanted to do this, you would say, all right, well, as we just did, I know that G is proportional to M. So if the mass is 3 times greater, that means that G is times 3. Okay, I know that G is proportional to 1 over R squared. So if R is 1/2 as big, if I take the inverse of that, I get 2, and I square that, and I get 4. So that means G is times 4 times as big. So that if I do this and this, that means my G is times 12. So that, hey, if I wanted to figure out what is the gravitational field strength on planet X, it would be 9.8 times 12. Okay, it would be like 12 G's. Okay, if you wanted to know how much more would you weigh on planet X than you do on the Earth, you would just take your weight on the Earth and multiply it by 12. Okay, now, bye kids.